So hello guys, today I'm going to show you how to flash, mount, and set up the ImpulseRC KISS PDB. So this was a collaboration with ImpulseRC, Flyduino, and MR STEELE to create a PDB for the Alien that supports all the KISS features. So you have telemetry, you have current sensing, OSD, black box, all this stuff. So yeah, and today I'm just going to show you how to mount it and flash it. So by the time of this video, it should come in a package like this. So we have, of course, the ImpulseRC KISS PDB. It has a pre-soldered microphone. We have the XC60 pigtail, some microphone foam. So basically, this will reduce the wind noise coming into the microphone. We also have the micro JST, I believe, or micro JST mounts. Or plug, sorry, and we also have the nuts that bite into the PDB, and then you don't need to use aluminium nut. And then we also have the screw set to set those in. So I'm just going to start off by opening the package. So we're just going to open it by the side here. So here is the PDB itself. It also comes with, I'm not sure what plastic, but this is just to prevent shorting. So I know a lot of people previously, they would use liquid electrical tape or just regular electrical tape to prevent the carbon from shorting on the original PDB. So this just comes with a simple plastic isolator from the carbon. So you don't have to use messy stuff. Then of course we got the pigtail. This is the new XT60 Plus, I believe, or XT60HM. So you don't have to use heat shrink, it's just this plastic wrap that goes around the solder joint to protect it. We have the microphone foam to reduce the wind noise. If I can get it out. So yeah, this is regular neoprene, I believe. So if you lose this, or if it falls off your microphone, you can go to your regular Home Depot or something and get some isolation foam for your doors and windows, and it's essentially the same stuff. So just mount that on your microphone and you'll reduce all the wind noise. We also have, of course, the JST plugs that connect from the PDB to the flight controller. So this is nice silicon wire. It's not gonna break over time with all the vibrations from the motors, so that's really nice. And they provide two with you. And then we have all the hardware to insert into the PDB, and then we'll be able to mount it. So we have all these inserted bolts, I would say, or press nuts. Not bolts, yeah, press nuts. So you're probably familiar with the old PDBs and maybe the V1.1 without the OSD. So you just set those in and you use a steel bolt and washer, and you just screw it, and then it will bite itself into the PDB. So they also include a washer and a bolt here, steel bolt, so that it doesn't just snap randomly, which alloys will sometimes. So 7075 and 6063 and 6061 aluminium, they will snap sometimes, so that's why they provide you with a steel bolt. So first off, we have all the connection pins here. It's all visible, so that's why they provide you with the isolation pad. It's essentially the same PDB, but with electronics on board, and it's going to be a very compact package when we put it in the Alien. So I'm putting this PDB in the ImpulseRC 4.5-inch Alien. So this 4.5-inch Alien. So the 4.5-inch Alien is slightly short. The body is slightly shorter than the 5-inch Alien, and it's also using 30mm standoffs. So I'm going to test that out. And yeah, so I'm going to show you how to insert the biting nuts into the PDB, and then we'll mount it on the Alien. So to put the biting lock nuts into the PDB, we're going to use a 3mm hex driver, and we're going to use the supplied steel bolt and washer. So first off, what we're going to do is we're going to put the steel bolt into the washer. This just provides protection to the carbon so it doesn't, or to the PDB so it doesn't scratch all the paint off. So that's what we're going to use. Come on, focus. Yes, there you go. Okay, so we're going to grab one of these biting lock nuts, and we're just going to insert it. So we have 8 positioning holes. So it's going to focus. Come on. There we go. So we have 4 positioning holes. We have 1 on the outside, 4, and then we have the interior, 4. So we're going to do that. And you should stop when you start to feel it, like you can't screw the bolt in anymore into the biting lock nut. So right about here, I can't do anymore. And also, if it's not fully tightened in, and if you cross-threaded it, make sure you take it out immediately and recenter it, because you don't want to bite the carbon in different directions and cause a larger hole to occur or anything else. So we're just going to do that to the other 7. So now we're complete. So I've inserted all of the biting lock nuts, so on all 8 of them. And yeah, so now we're going to essentially just solder on the pigtail and then solder it all up, put it in the PDB. I'll show you how to connect it all, and then we're going to connect it to the computer to adjust the settings and adjust the KISS FC settings so that it communicates with the PDB. So I've soldered the XC60. I didn't use the stock one just because I want a different color, but honestly the stock one was soldered perfectly, so I would use the stock one if you don't want to do the extra job of just adding a different color. But yeah, so I did that. I soldered that to the bottom. And another thing is, especially with the Alien stuff where the pads are exposed like this, like that, and very close to each other, what I do is I add some silicon conformal coating, and I add that on the bottom here. It's transparent so you can barely see it, so it will still look good. Oh, there you go, you can see a little bit. So I put some there, and I also put some, where's that? I put some there where there are pads visible. There we go. So yeah, just to add some protection. And then also what you're going to want to do is you're going to want to grab the neoprene foam. There's 2 different ways. Come on, focus. There's 2 different ways of mounting the neoprene foam. One way I saw is, or one way that I just figured out, use it like a muffler essentially, so to prevent the wind noise. Come on. There we go. So as a sort of as a muffler, so I added a little strip of neoprene like this, and I just cut a round circle. Like I sticked it on, cut a round circle, and then I cut it a bit shorter, and then I used just a simple lighter, and I heated it up to mold it to the perfect shape, and that's how I got that nice round shape. Now, other people that have this PDB, they've grabbed the so here's the 4-inch body or main plate, so they just put this on there, and then they put a little piece of neoprene. They stick it on the frame right there to prevent the noise. But I'm just going to test it out by directly mounting it on the microphone. So yeah, next up I'm going to mount this on the frame with the arms and screw it all together. Also, don't forget the plastic isolation pad. Never forget this, because it may short out the bottom of the PDB because there's a lot of connections and traces going there. So make sure you do that. After that, I'm going to show you how to connect it to the KISS FC, and then we're going to flash it if you have to flash it, and then we're also going to change up all the settings. I believe you can do it via the radio, but we're going to connect it to the computer as well. So I have soldered up all my ESCs. I've added all 3 wires, the PWM, telemetry, and ground. And essentially all you have to do is once you've soldered on your motor and all your wires, well, this is at least how I do it. Now I'm going to mount it with some electrical tape, cut it, strip it, pre-tin, and then solder it. So yeah, and then also don't forget your little JST for the ports for the KISS FC. So you should have 2 of these with the silicon wire. Those just connecting there after we're done soldering. So here's the KISS PDB. I've soldered on all the ESCs. I've added all the PWM and telemetry wires. On all the 4 ESCs, I've also added the VTX for the Unify 5V and also the camera wires. I've also added some hot glue to reduce the strain on the solder joints due to vibrations. And yeah, that's about it. So now we're going to go ahead and connect the KISS FC. So as you can see right here, they're labeled ports. So let this focus. Almost. Okay, there you can see port 1 on the left and port 2 on the right. So those are the same as port 1 and port 2 on the KISS FC, which I have right here. So you'll see one port is labeled, the other is not. So you'll see port 2 on the right, and then the one with the diode, I believe, that's just port 1. So just put port 1, and port 2, and you should be good. So now I'm going to put the KISS FC on, solder on my receiver, which I've already pre-tinned the KISS FC, and then I'm going to show you how to flash it and how to set it all up, configure it in the FPV camera and all that. So yeah. So with the Unify, you can either use smart audio or audio. So if you wanted to use audio, you would have to solder onto the audio pad. Where's that audio pad? So there's an audio pad over there. You could have soldered there. However, I opted to go with smart audio. So I just soldered the audio from the Unify cable to the RX3 pad on the KISS FC. And now I can change my VTX settings and everything from the OSD and from the Lua script on the TRAS. So unfortunately, yeah, you can't do it from the audio directly currently. However, in the future, I think they're going to fix that, or Alex will, as well as Sean. They're going to make sure that you can use smart audio and audio at the same time with the Unify. So once you solder all this up, there are a few things you want to do. So what I've done is, especially with the Unify, unfortunately, you'll have to either choose between smart audio or choosing the audio from the microphone. I opted for smart audio because I wanted to change channels and power through the Tyrannus via Lua script. There are ways of using audio and smart audio together on the Tramp, or on the Unify, sorry. You just have to use, I believe it's a 100 NF capacitor, or you can use a certain resistor. I'll put the graphs and the links in the description below and also in the video, so you can see if, and you can experiment which one will work best if you want to use both, but I just opted to go with smart audio because that's what works and that's what I want. So what I've done is I've unsoldered the I've unsoldered the audio, so there's no audio anymore. And from the Tramp, from the Unify cable, I used the white cable is the smart audio, so I just wired that, and that goes to the bottom of the KISS FC to RX3. And yes, I am using the 1.3 on the KISS FC in order to do that, and also to reverse the motor direction through software. Another thing that I've tested, I've done a few test flights already on this, and you have to, if you're using powerful motors, for example on this build, I'm using the Hyperlite motors. So these are 2207, 2522 kV motors. So especially on these, they do a lot of rush current to the PDB, so it gets lots of voltage spikes. So what I've done is I've added a capacitor, and I've sold that directly underneath the PDB. This is a 1000 microfarad 25 volt capacitor. Now you could do 35 volt, but I had 25 volt laying around, so I just put that on and it works fine. So all I've done is I just soldered that to the bottom of the PDB, of course plus and minus, because electrolytic capacitors are polarity sensitive, and I've gone ahead and soldered that to the bottom of the PDB, and I've also added some conformal coating as well, just to protect it from shorting. So I'm just going to do a quick test flight to show you what the capacitor does and how it helps with video. I'll show you a before and after video to see what happened before when I didn't have the capacitor, and now what I have when I added a capacitor. So this is with the new capacitor. I still have to tune this quad, so. But as you can see, when I do hard rolls, hard flips, there's no black blips or anything power surges like that. So I still have to tune this quad, but the OSD works perfectly with the capacitor installed, and I just have to tune my quad and we should be ready to flash the firmware. Okay, so now we're going to go ahead and flash the STEELE PDB. So what we will need is, of course, the quad with removed props, so make sure you remove the props. We're going to need a battery, some tweezers, and of course a micro USB cable. So first off, we're going to have to go online. I'm going to put all the links in the description below. We're going to go ahead and download the latest KISS OSD firmware for the STEELE PDB, and we're going to get the latest KISS GUI and all that. We also need Xloader, and I'll just leave all the links in the description below. So first off, here we have, this is ImpulseRC.com. We're on the STEELE PDB page. So you can just go here and review the schematics, so you can see where all the pinouts are. So here we have the camera to VTX and then to camera. We have the ESC, ground, telemetry, and PWM. There's also a jumper for 5 volt and 7.5 volts. And then there's, of course, the 2 ports that go to the FC. And remember that the PDB port 1 has to be plugged into the FC port 1 and also port 2. So make sure you didn't reverse any of those, and you should be all good. So now we're going to go to, so this is just wiring up several other OSDs, and there's also links to the GitHub page to download the firmware for the STEELE PDB. Here is the RC Groups forum page about and they give you all the change logs and everything about the KISS OSD and the STEELE PDB. So that's that. But this is the main page that we want to go on. So it may be different. It may be RC5, RC6, or 2.5. I don't know. But at the time that I release this video, it should be version 2.4 RC4 for the STEELE PDB. So here's the STEELE PDB, and you're going to want to go to the downloads right here. And as you can see, there's STEELE PDB v2.4 rc4.zip. So we're going to go ahead and click on that. Here's the STEELE PDB v2.4. So I'm going to go to my desktop and I'm going to click save. So it's already saved to my desktop. Now I'm going to exit out of here. So as you can see, here is the STEELE PDB v2.4 rc4. I'm going to open this up. So here I use WinRAR, so you might have a different zip, but just grab the folder in here and we're going to drop it into the desktop. I'm going to do that. So here's the GitHub release. So we're going to click on that, and I'm on Windows. There's other OSs that you can use, but since I'm on Windows, I'm going to click on the Windows. And here we have all the OSD stuff. So we have, as you can see, we have 2 hex files. We have the config tool hex, and we have the OSD hex. First we flash the config tool, then the OSD. So here we have Xloader, and this is what we're going to use to flash it. So first off, you're going to grab the quad, and we're going to disconnect the port 2. So that is the port on the closest to the left of the board, if you look at it from the left side. So you can use just your fingernails to pop it out. It's not super hard to fit, or you can start using the tweezers a little bit to disconnect. There we go. So now that it is completely disconnected, if it's going to focus, it's completely disconnected, so there's no power going to the FC. So when we plug in, we will see that the ESCs won't receive telemetry or PWM, so they will not do the second boot tone. So now we grab the micro USB, and we're going to go ahead and plug this into the STEELE PDB. We can also launch Xloader right now, so I'm going to go Xloader. So once you open up Xloader, it should look like this. I can't make it bigger, but it should look like this. So we have the hex file that we're going to choose. We have the device, and we also have COM port and baud rate. Let's select the COM port. So when you plug in, you should see that there's a different COM port that is being recognized. So you want to click COM port, the COM port that was just recognized. And we want to make sure that it's at mega or uno / at mega 328. So we're going to click on that. And then we're going to click on find the hex file. So the hex file, you can go to or find the GitHub release and then Windows and then find the hex files. So first we want to flash the config tool. And the config tool is basically to configure all the settings. Like if you want imperial, metric, Fahrenheit, centigrade, you can choose what icons you want, where you want to place your milliamps, amps, voltage, all that stuff. So we're going to want to flash the config tool first onto the OSD. So we're going to click on that, so it should be flashing the config tool. Now we're going to go ahead and plug in the LiPo battery. So you can see the ESCs didn't light up again, so they didn't turn on the main LED, so that's because the FC is not getting power. So now we're going to click upload. And you should see that it is uploading, and soon it will tell us how many bytes was uploaded. Once it tells us how many bytes was uploaded, we can disconnect the battery and disconnect the micro USB. So here it says how many bytes was uploaded. So now we can disconnect the battery and disconnect the micro USB. Now I'm going to go ahead and grab my FPV goggles. I'll record the DVR, and I'll also get my transmitter so that we can configure the OSD, because that's how you configure the OSD, through the transmitter. So remember to plug in port 2 again. So plug that in, use the tweezers to help. Make sure you do it gently and make sure it's all centered so that you don't bend a pin and accidentally short something, or a pin is not connected. So let's do that, and then I'll go get my goggles and transmitter, and then we can continue with the configuration, and then we'll flash on the main OSD firmware. So now that we have the configuration hex file flashed to the PDB, I'm going to go ahead and configure it now using the radio. So with the Steel PDB, we don't use MinimOSD to configure it. We just use the radio to configure it because it's simpler, and the reason there's 2 hex files is because the flash chip can't handle both at the same time. So we have to flash one first and then the secondary. It's a bit annoying, but that's how it is now. There should be versions in the future that will adjust that and have a larger flash chip. But so now I'm going to power on my goggles, power on my radio, and then we're going to power on the quad. So now that the quad is powered on, and also make sure that you don't keep it powered on for too long time, because you can overheat the VTX and damage it. So now I'm going to go to the display, and I'm going to record the DVR so that I can show you all the settings that I've adjusted. So I'm just going to grab my radio, and I'm going to update the font. So it's updating. And to change settings and to go to settings, you can roll right, and then to exit you can yaw left, and then to go up and down its pitch. So now that the font has been updated, I'm going to go to the display and reduce items. I'll leave it on fixed. RSSI, it's off because I don't have it in. Temperature units, centigrade, font size, large. Icons, you can adjust the icons. I usually just turn off all of the icons. Back. Here we have the goggle. You can head play or Fat Shark, and I believe that's either NTSC or PAL. So I'm using Fat Shark, so that's why I'm gonna stick with Fat Sharks. Watt meter, you can leave it on or off. I chose it off. Crosshair, statistics hidden. So if you leave the statistics hidden, what it'll do is once you've disarmed, you can check out the statistics of all the ESCs and temperatures and stuff. So that's all done. I'm going to go back. Call sign, you can do your call sign, but I've already added the call sign onto the FPV camera. It's my battery, sorry. So I'm gonna yaw left, exit. I can move the items, so all of the items are already preset. I added a few other things. So I'm just gonna exit. Let me turn on my fan. Sorry, I forgot to do that. So now we can go to center the OSD if you want to change that. I'm going to exit. Set items. I can choose if I want my call sign on the OSD, timer, throttle, amps, voltage, milliamps, ESC RPM, ESC amps, ESC temperature, and RSSI. The battery, we can set the alarm, 25%, battery warning, I'll leave that on. Voltage warning, you can set the minimum voltage, you can set a voltage correction, watt meter max and all that. VTX, you can adjust the VTX max power output as well as the channels. Now I'm just going to hit save. So all my settings have been saved, and now we can disconnect the battery from the OSD and we'll flash on the actual OSD now.
Telemetry lost.
So to flash the main OSD firmware onto the PDB, we're going to have to disconnect port 2 again. So that's a bit of an annoyance. So we're going to go ahead and disconnect port 2 again. Gently disconnecting it. Now that port 2 has been disconnected again, we're going to go ahead and connect the micro USB to the PDB. And we're going to choose all the same settings, except instead of the config tool hex file, we're going to actually choose the OSD hex file. So I'm going to go ahead and open that up. So now we can go ahead and power on the OSD again. Now that it's being powered up, I can click upload. So we'll upload all the data from the OSD, and it will save the configuration as well. So once it's done uploading, you will see that it has uploaded about 30,000 bytes. So now let's go ahead and disconnect the OSD again. Disconnect the power, and then disconnect the micro USB. And then we're going to go ahead and connect the port back. And now you should be ready. So we're going to go ahead and see if the OSD works. We're going to arm it a bit and see if milliamps work and amps. And then we're going to go ahead and test and go to the KISS FC, and I'll show you how to download the new GUI as well as set up the OSD within the GUI. So go to the peripherals and select OSD. So let's go ahead and put the goggles on, turn the radio on, and test to see if everything's working properly, and then we can go ahead to the next step. So to test the OSD, I'm just going to plug in power. So everything's fine there. Initialization tones. Good, find the channel. So as you can see, we have the voltage, we have milliamps, and we have amps. And then at the bottom I set my throttle so you can see it changing. So if I arm, you can see amps work and milliamps work. And the voltage is changing. So that's all nice, and it all works properly. And as well, you can go to here we have the time, the max amps. We can go through all the data and through each individual ESC as well. And if you're wondering how to change like change all the settings within the OSD firmware, or change some settings, we're gonna do a long on the Tyrannus. We're gonna do roll to the left, to the bottom of the left for about 3 seconds. And in our OSD, we should see that we have the Steel OSD V2.4 main menu, so we can change up the tune. We can change the TPA. We can change the filters, battery. We can adjust the battery alarms and stuff. We can change the VTX channels and power. We can go to the icons. We can set them off or on. Timer, we can add the timer. We can add the crosshair, and we can do all that.
Ignition.
Oh, everything works.
Ignition.
So now we're going to go ahead and configure the OSD, or configure the KISS FC. So you may have to do this beforehand if your KISS FC doesn't have the latest 1.3 firmware. So right now I'm just going to show you how to flash that on the KISS FC.
Telemetry lost.
So now we're going to flash the KISS FC with the latest 1.3. It's your standard process of flashing. I've already flashed it, so I won't really show you how to flash it. If you're Mac, you can use the GUI. If you're PC, you're gonna have to use we're gonna have to use diffuse demo. So we're gonna select, it's gonna automatically go to the DFU device. You're gonna click choose, and you're gonna find the KISS FC 1.3, and you're gonna upgrade. So that's your standard way. But I will give you links on where to get this, the bundled firmware for 1.3, because you will need the bundled firmware, because this includes the new GUI which you need for using version 1.3. So once we've downloaded that, we're gonna get the bundle here. So here's the bundle. So as you can see in here, we have the Lua scripts, which you'll need to install onto your Tyrannus, the new Lua scripts. We have the KISS FC Wi-Fi, I'm not using that. We have the KISS FC 1.3 RC10, so that's for the FC, so we're going to open that up, and in here we will have a hex file and a DFU file for Mac or PC users. And then we have the new KISS Chrome GUI, so if we open that up, we get all this. So you're going to be, oh, how do I open up the GUI, or the new GUI? How will where's the .exe file? But there's actually no .exe file. This is all in just basically what's inside all the Chrome applications. So I'm going to teach you how to set this up in Chrome. And then we have KISS CC, and then the new KISS 24 amp. So that's your standard way of flashing the new KISS firmware. Just go to the GUI, click Flash ESCs, accept that you could explode an ESC, do that thing, and then we're gonna flash and then you just flash the ESCs. So that should take around 5 minutes. But since I already have that all installed, the main thing that a lot of people have issues with is installing the KISS GUI, or the new KISS Chrome GUI. So this is the 1.16.4. So in here, how you do this is you're gonna make a new folder. So I'm gonna make a new folder. I'm just gonna call this KISS GUI. I already have that, so I'm just gonna toss that in the garbage. So I have KISS GUI, and I've imported all of this. I've just done this and copied it into the into that folder that I just created, and I did that. So once you've done that, you have all the files here. We're gonna go ahead and go into Chrome. So we're gonna click the 3 dots vertically here. I'm gonna go to More Tools and Extensions. So here, as you can see, I have all this. So I'm gonna go Load Unpacked Extensions, and I'm going to find, so I'm gonna go to, where is that? To desktop, or sorry, this PC, desktop, and here I have the KISS GUI. So if I click OK, it's going to open this. I already have it open, but once you click OK, it should open this up. So now that we have this, we can click on Launch, and here is the GUI. So yeah, this is the new GUI. It should say 1.16.4, select your language, English, and that's all good. So now we're going to connect the USB to the GUI, or sorry, to the FC. So it should recognize, and we should see a new COM port 7. I'm going to click connect, and here's all these settings. So I believe when you first flash it and do all the setup, you have to activate it. I've already activated it, and here's all my settings. So this is all the settings. There's nothing here about the OSD that you have to care about. Maybe your VTX power, so just set that on a knob. So you're going to go into your Tranis and set up another channel and set up the knob. So the main stuff is in advanced. So we're going to go into advanced, and we're going to see that we have a serial config. And in the device, we're going to select OSD. Usually it should say OSD from the start, but sometimes it could say a logger. So we're going to make sure it's OSD. And then VTX config if you're using a Triumph or a Unify. I'm using a Unify, so I just set that there. And that is about it. So remember to click save on all the pages, and disconnect. And your OSD should be working, and KISS OSD should be working, and everything should be working great. So yeah, that's it for this tutorial, I guess. I hope you guys enjoyed it. I hope you found it helpful. Comment down below if you have any issues, and I'll do my quickest job to reply and help you with those issues, so that we can get that sorted and you can get flying. So yeah, I'll see you in my next video. I should be releasing a flight video of this new build reasonably soon. I might go to the mountains and some dunes nearby. So yeah, I'll see you guys next time, and I hope you guys enjoy the Steel PDB, because it took ImpulseRC and Flyduino a long time to design it. I know a lot of you guys were impatient and started getting new frames and stuff, but I think it was worth the wait because it's an excellent design, it works great, and it's super simple. So yeah, I'll see you guys next time.